Hello. In this video, I would like to share with you different ways we analyze data when describing group behavior. Some of the vocabulary terms will be familiar to you and some will be new. In either case, I would like to focus on the activities and examples at each step, and you can spend more time on your own researching the terms or phrases for which you need more practice. For the first three activities, we will use the following scenario. A teacher would like to analyze the data he collected from his group of 28 students to decide whether it is appropriate to move the class on to the next topic. The scores on the most recent quiz are reported in the table. While it might be possible to make a decision by looking at this collection of scores, a better way to view this data is to organize it into a frequency table, which displays the number of entries within specified intervals. A quick look through the data reveals the highest score is 98 and the lowest is 60. Let's say the intervals are grouped by 10, 60 to 69, 70 to 79, and so on. Technically, each group should be the same size, but realistically, I would have included scores of 100 in this last group as well. Now, take the time to count the number of entries that fall into each group. Pause the video now and resume playback in a moment to check your work. This is a little better than looking at the raw data. At least we can tell there is a large number of students that scored in the 60s, and close to an equal number of students scored in each of the other groups. For those that are more visual learners, or if there were more groups of data, translating this data into a histogram might be more helpful. A histogram is a bar graph that shows the frequency of data values in intervals of the same size. Since we already counted the number of entries within each interval, we can create a bar graph of the data to visually see the pattern. Notice that I made the height of the bars represent the count, and the width of the bars are not important since they represent intervals or bins of data. Visually, we see the group tended not to perform well, but another way we can describe the performance of the group is by calculating mean and median, which is meant to determine where the center of the group stands. In order to calculate the mean, you must compute the simple average, which is the same as the sum of all values divided by the count, or number of values in the data set. In doing so, you would find the sum of these numbers is 2,147, and when divided by the count, 28, we see the mean, or average, is 76.7. I am not convinced that this is the best measure of center, since there were so many of students that scored in the 60s. Another measure of center is the median, which is the middle value of an ordered list. If we were to take the time to order these numbers from smallest to largest, it would look like this. And the middle of the data would be found here. Had the list contained an odd number of entries, we would simply take the number in the middle as the median. But since there is an even number of entries in this list, we take the average of the middle two numbers, which is 76.5. Interestingly, the mean and median are quite close to one another. But this isn't always the case. We will discuss when it will be appropriate to use mean and median in a few moments. First, let me remind you of spread, or how the data varies. The standard deviation is used to measure the typical variation of numbers within a set. It requires that you compute the mean of the data first. For each number in the set, subtract the mean and square the result. This will give us a number that is always positive, whether the value is above or below the average. Compute the mean of these squares next. Then take the square root of this answer to undo the square from the second step. This is quite a tedious process that can be simplified if you use a calculator or computer with the capability to compute the standard deviation of a complete set of numbers. With the standard deviation, you can describe how the results spread out from the measure of center. Another option is to use a 5-number summary to explain the spread. This contains a list of 5 numbers, the minimum value of the set, the first, second, and third quartiles, and the maximum value of the set. You should recall from another class that the first quartile is simply the median value of the lower half of the data. And the third quartile is the median value of the upper half of data. And the second quartile is simply the median of the entire set. The minimum and maximum are the smallest and largest numbers from the set. Usually, we would use the mean to describe the center and the standard deviation to describe the spread for data that appears symmetric. That is, when the data to the right and left of center are approximately mirror images of one another. This would also include data bars that are all close to the same height, or a uniform distribution, which is also symmetric. For data that is non-symmetric or skewed, we usually use the median to describe the center and the 5-number summary to describe the spread. The reason for this is because more of the data points occur to the right or left of center on each graph. Also, outliers, or numbers that are much larger or smaller than the rest of the data, can significantly change the mean. The median is resistant to the impact of outliers. To finish this video, we will look at 2 new scenarios. In example 5, we have a list of dollar amounts you were paid while working your part-time job last year. I would like for you to display this data in a histogram with the provided scale. Then decide which measure of center and spread would be the best to represent the data. Be sure to use the reasoning from above to explain why this would be the case. Please pause the video now and resume playback in a moment to check your work. Since the data is skewed and not symmetric, the 5-number summary would be the best to describe the data. Half of all of your paychecks were less than $75, and half were more. 1/4 of all of your paychecks were between $30 and $50. Another fourth were between $50 and $75. Another fourth was between $75 and $115, and a fourth between $115 and $200. For our final scenario, we have two stores that have reported the number of weeks employees have requested for vacation in particular months. Please plot the data in a double histogram, one for each set of data, and compare the distributions using their shapes and appropriate measures of center. Your histogram should look like these, and your comparison might sound something like this. Because the data values on the right of the distribution for store 1 are approximately a mirror image of the data on the left of the distribution is symmetric. So the mean and standard deviation best represent the distribution for store number 1. Because most of the data values are on the right of the distribution for store number 2, and the tail of the graph extends to the left, the distribution is skewed left. So the median and 5-number summary best represent the distribution for store number 2. The mean of store 1 dataset is probably in the May to June interval, while the median of the store 2 dataset is in the September-October interval. So a typical employee from store 1 is more likely to use vacation time in the late spring, whereas a typical employee from store 2 is more likely to use vacation time in the fall. The data for store 1 is more variable than the data for store 2. This means that the use of vacation tends to differ more from one store 1 employee to the next.